The next topic is vectors in R3, spatial vector with the notation IJK notation. Vectors in R3 are called spatial vectors, appears in many applications, especially in physics. In fact, a spatial notation is frequently used for such vector. The first one is I100 denotes the unit vector in the x direction. J010 denotes the unit vector in the y direction. These are called unit vector because their length is equal to 1. Their norm, I norm is 1, J norm is 1 and K norm is equals to 1. So these are called unit vector. Then any vector u which is a, b, c in R3 can be expressed uniquely in the form of u equals to a, b, c can be written a times I plus b times j plus c times k. It is k, not j here. Like as you can see that any vector, it is your u vector a, b and c. It can be written as a times 1 0 0 plus b times 0 1 0. If we multiply these vector, these component a, b, c with 0 1 1 0 0 0 1 0 0 0 1, here you can see it will again give you it can be written as a00 plus 0 b0 and plus c0 0 and c. When we sum these vectors, it will become a plus 0 0 0 0 plus b and it's c. It can again written in the form of this vector, but here it can be written a times I plus b times j plus c times k. So any vector u can be written in the form of these spatial vectors. Okay, then we have some properties of these vectors. I, j, k are unit vector and are mutually orthogonal, mean their dot product is mutually. I dot j is 0, I dot k is 0 and j dot k is 0, mean these are orthogonally or perpendicular to each other. Like if we have an xy plane, it is your xy plane. If it is your x vector, here we have 1 0 0, here we have 0 1 0. It is your y vector and it is along y axis. This is your I vector and this is your j vector, and here we have 0 0 1. It is your k vector. So you can easily see that these are orthogonal to each other. So that's why I dot j is 0, I dot k is 0 and j dot k is 0. But their dot product with itself is 1. I dot I is 1, j dot j is 1 and k dot k is 1. Okay student. So with the help of these vectors, we can add any two vectors to u plus v. If we have two vectors u and v, we can also add these vectors. We can also take their dot product with each others. And we can also take their dot product itself. So here is the example, very simple example. You can study this example. You will have no problem in this. Then we come to the cross product. Last time we discussed dot product. Today's our topic is about cross product. There is a special operation for vectors u and v in R3 that is not defined in Rn for n is not equals to 3. This special operation is defined in R3. This operation is called the cross product and is denoted by u cross v. Okay. It is to be used to determinant and its negative, which is denoted and defined as follow. If you remember the determinant of a vectors a, b, c, d, so it is ad minus bc, and if we are taking minus time ac, b, d, so it will be bc minus ad. Here A and D are called diagonal element and B and C are called non-diagonal element. Thus the determinant is the product AD of diagonal element minus the product BC of non-diagonal element, but vice versa for the negative of the determinant. Suppose we have vector U, which is A1I plus A2J plus A3K, and V is equals to B1I plus B2J plus B3K. Then their cross product is U cross V is, we are taking is as the determinant, simple determinant. It can also be written as in the form of A1, B1, A2 and B2, A3 and B3 times I, minus again this determinant plus again this determinant. In this case we are ignoring this column and taking the determinant of this portion. Minus time, in this case we have negative determinant. We are ignoring this column and taking the determinant of these remaining two columns, plus we are ignoring this column and taking their determinant. It can also simply be written in the form of determinant of I, J, K, A1, A2, and is it A1, A2 and A3, and B1, B2 and B3. You have some idea of cross product from your FSC course. We are taking I, then ignoring this row and ignoring this column. A2, B3 minus A3, B2. For J we have negative sign, ignoring this row and this column. It will be A1, B3 minus A3, B1 plus K time. For K we ignore this third column, first row. So it will be A1, B2 minus A2, B1. So it is your simple cross product of two vectors U cross V. So you can define the cross product between two vectors U cross and V. It is simple, they are mentioning their method, तो इतना कोई ख़ास ज़रूरी नहीं है. मैंने आपको बता दिया कि कैसे डिटर्मिनेंट से हम फाइंड करते हैं. They have given two examples, so simply use these examples to find the cross product of vectors. Then the cross product have some properties, that I cross J is equals to K, J cross I equals to I, and K cross I equals to J. But in this case, if we are rotating this, then it is not commutative law. It is not holding the commutative law. It will give you the negative direction. J cross I equals to minus K. It is the same way. If you remember I, it is a circular form. If you remember, have any idea, J and k. If we move in this direction, I dot j, I cross j is k, j cross k is I, and k cross I is j. But if we go in this direction, then it will be negative. It's your anti-clockwise direction. But if we go in clockwise direction, but if we are taking anti-clockwise direction, then it will be negative. Okay, so here we have a theorem let u, v and w be vectors in R3. The vector u cross v is orthogonal to both u and v. The absolute value of the triple product u dot v cross w represent the volume of the parallelepiped formed by the vector u, v and w. So it is the formula of volume of parallelepiped. And then we use the vectors u, v, u cross v form a right-handed system. And that following formula gives the magnitude of u cross v. So it is the magnitude of u cross v. U cross v norm is equals to u norm, v norm and sine theta, where theta is the angle between u and v. It is the formula of their magnitude of u cross v. Okay, then we have complex number. So I will start this video in another topic. I will start this topic in another video. Thank you student for now.